Here we have the situation of a horizontal line. If we write our ordered pairs, -7, 5, 5, 5, we can use the formula to find the slope. However, once again, when we know for certain we have a horizontal line, we know that the answer for the slope is going to be 0. So we don't really have to go through all this, although we will just to show that the answer is going to be a 0. So we'll take the second y, 5. Subtract the first y, 5. That's the second y here. First y here. Subtract those for our numerator of our slope. Second x, 5. Subtract first x, -7. Minus minus situation makes a plus. Ultimately here it doesn't matter though. 0 divided by 12 is going to be 0. We have a 0 slope. Anytime there's a horizontal line, the slope is going to be 0. Why? Well, there's no rise. When you look at this line from left to right, it's perfectly flat. So in the case of the vertical line, straight up and down, perfectly straight up and down. Got a lot of rise in that line. But remember, the run of a vertical line is 0, making the denominator 0. So the slope of a vertical line, like we saw previously, is undefined. But the slope of a horizontal or perfectly flat line is going to be 0. Sometimes we won't have 2 points on the line. Instead, we'll have an equation. And we can actually find the slope of a line from its equation. Let's say we have this equation, 2x plus y equals -4. We could find points on the line, like we've been doing. Find points that satisfy this equation, and then go through the process of using the slope formula. There's another way to do this that's a lot faster, however. There's a special form of the equation of the line that's called the slope-intercept form. And when your equation is in that particular form, you can look right at the equation, you can tell the slope, and you can tell the y-intercept, or the place where the line is going to cross the y-axis. That format happens to be y equals mx plus b. And in that format, the slope is right here, the coefficient or the numerical part of the mx term. And the intercept is this constant value on the end. So this is your y-intercept, and this is your slope. So all I really have to do is one step in order to get this equation into this format, and that is to move this 2x term to the other side. Now to do that, I would have to subtract 2x from both sides. And rewrite that equation as y equals -2x. I'm going to put the term with the x variable first. Subtract 4. That is in the slope-intercept form. Anytime the equation is solved for y, your slope is going to be located as the coefficient of x. Your y-intercept is going to be this constant value. Identifying those to be -2 for slope, and I'll use the letter b, which is used for the y-intercept, is -4. So we have all the information we need now to draw a sketch of this line. We start with the y-intercept on the graph, so we'll locate that at -4, and we'll use what we know about slope, rise over run, put a denominator of 1 here, to move along that line and find some other points on the line. we have a negative slope, meaning our line's going to be falling. So down 2, 1, 2, to the right 1, down 2, to the right 1, down 2 to the right 1. Now I'm going to sketch in my graph by connecting these points. And that is my graph. Y-intercept is -4. Slope is -2. I could verify that I have this graph right by taking a look at any of these points I have graphed. For example, this one is 2, -8. If you look at that third point down that I just graphed. Let's check it in the original equation just to be sure we have our graph in the right place. 2x plus y is supposed to be -4. So I'm going to substitute these values in. X is 2 from my ordered pair, plus y is -8. And then I'm going to double check to make sure that this point is actually on this line and that I've got the graph in the right place. Well, 4 plus -8 combines to be -4. And that's what we have here for this equation. Our value on the right was -4, so this is true. This works out just fine. So we've written the equation in slope-intercept form. That is the y equals -2x minus 4. And from that, we've drawn the graph, and we're able to locate other points, and we're able to see the y-intercept. Now, when we first started talking about functions, we mentioned that the most common way you run across functions are through verbal descriptions. And this is true with the slope of a line as well. So here's a verbal situation, and we're going to be asked to find the slope and figure out what does the slope or rate of change in this particular context mean. So the problem says the cost to rent a car for a day is a flat fee of $89 plus $1.20 per mile. So we've got a fixed amount of $89 and we've got a variable amount of $1.20 for every single mile the car is driven. We're asked to write an equation in slope-intercept form to express the relationship and then answer some questions that follow. Now, keeping in mind, slope-intercept is y equals mx plus b. And you could use any value for your function name. Instead of calling this y, I might even call this c of x or c of m, where m is miles. But I'm going to call it in function notation c of x. I'm going to define my x to be the number of miles driven, because this is a linear equation or function, and it depends, the outcome of this, the cost, depends on how many miles that car is driven. What is the variable part or the slope or the changing part that we're given? For every X mile, we have to pay $1.20 times that number of miles. So there's your $1.20x. That's your slope of your line. And what is the flat or fixed amount? It's $89. So here's our situation. We have a flat amount that we start with, $89, and then we go up by $1.20 for every mile we drive. That is your slope-intercept form of the equation. You could actually sketch this graph. The y-intercept would be at 89, and then it would go up slowly $1.20 for every x. So, looking at the slope and the y-intercept, what can we answer for part A? Slope is $1.20. But what does that mean in terms of change? So we want to describe this slope in the context of this problem and interpret it as what it really means, and keeping in mind that slope means how things are changing. We know that the price or the cost is going up by $1.20 per mile. Cost increases by $1.20 per every mile driven. And write that as a ratio, 1.20 per 1 mile, or you can just put $1.20 per mile. Part B, what's a y-intercept? Well, remember in this form, y-intercept is that value. It's out here. Y-intercept is, our B value is 89. Now remember where that y-intercept is. If I take a little quick sketch of this graph, this guy would be at 89, and it'd be going up some. Cost is going up. 89 is where we start with 0 miles. C of 0 would come out to be 89. If I put a 0 in for this x, I would get 89. So even if we don't drive that car, we have to pay, if we rent it, we have to pay that $89. That's your flat fee. So you might interpret this as saying the fixed fee or flat fee, 89, no matter how many miles you drive. Even if you drive 0, you've got to start out with a cost of $89. Now they want us to actually use this formula we've written. We've come up with this linear function or linear equation, and we want to use it to actually solve a problem. So looking at what we want to find here, let's have a little more space. Find y if x is 100. So I could say find c of 100. That's the same as saying find y if x is 100. That means in place of x, I will put the value 100, then multiply it by 120, add it to 89, come up with a value, and now interpret what it means. What is the 100? The 100 is the x. What is the x in this problem? Miles driven. What is the y in this problem, or the outcome, the output? It is the total cost. What we have here is that the cost to drive 100 miles is $209. The cost for a 100 mile, and we're just assuming 1 day, 100 mile rental is $209 to rent that car at that rate that we're given, paying that extra $1.20 per mile. That flat rate of 89 comes out to be $209 for a 100-mile rental. Part D. Let's find x if y is 483.80. And what does that mean? So we take our equation, and instead of our y, we put 483.80. And we don't know the x this time. And what we're really asked to find is x, and x is the number of miles that we drive that car. So we'd have to do a little bit of arithmetic here. We'd have to take 483.80 and subtract 89. So I'll switch over to the calculator here. 483.80. Subtract from that the 89. So when I do the arithmetic of 483.80 subtract 89, I get 394.80. And then the last thing to do to solve for x is to divide both sides by the $1.20. So once we do that arithmetic of subtracting 89 from both sides, then dividing by the $1.20, we get 329. Now the interpretation of this in the context of this problem is that a rental for $483.80, we got x is 329 here, if the total cost is $483.80, that was, we were given the y, which is the cost, we know 329 miles were driven. So in a linear function where we know the rate of change and we know the constant amount, the y-intercept, we may be asked to find the y value if we know the x, or we may be asked to find the x value when we know the y. You just have to watch carefully what they're asking us to find. So one last example here regarding what is called break-even analysis. When you start a business, or when anyone starts a business, the first few years you have a goal, and that is to not lose money. You want to make money, but more than anything, you want to not lose any money. You want to at least break even. That is, your revenue and your cost are at least equal to each other, or you bring in more so that you can make a profit. I mean, ideally you'd make a profit, but you may not the first few years. But you've got to figure out what is that break-even point so that you have a goal of, when starting this business, you know, how many do I need to sell to at least break even, not lose any money on this venture? Here's what we know about Micah. She's starting a business and she's going to sell t-shirts. Her estimated startup costs, so a one-time startup costs are $800. But it's also going to cost her $8 per t-shirt. I guess that's to buy the t-shirts and to get them printed, or even to distribute them, whatever, $8 a shirt. Then she's going to sell those t-shirts at $18 each. We want to write a cost function to figure out how much it cost Micah to make these shirts. Now her cost is made up of two parts. Micah's cost to make X shirts is $8 a shirt. But don't forget, Micah is out of pocket an original $800. That's her fixed amount. Now we could talk about the slope and the y-intercept here. Slope is 8. What is changing? The cost per shirt is $8. So her additional cost for every shirt she makes is 8. So her costs are going up, increasing. This is a positive slope. It's an increasing amount per shirt. What is her revenue function? Well, her revenue has absolutely nothing to do with her costs. Her revenue is strictly based on how many shirts she sells, how much she charges for those shirts. So her revenue, according to our problem, is $18 times every shirt that she sells. When does Micah break even? When C of X, her costs, equal to R of X, her revenue, Micah will exactly break even. She brings in a certain amount, it matches with the amount that she has to pay out, It's called breaking even, and that's a good thing at the startup of a business. Obviously, profit is a long-term goal, but starting up, she just wants to know, how many shirts am I going to have to make and sell to at least break even this first year of her business? Take that revenue function, set it equal to that cost function, or that cost equal to the revenue. Which side you put it on doesn't really matter. Subtract 8x from both sides. 10x is 800. Divide both sides by 10. Her break-even point is 80 shirts. Micah's got to make and sell 80 shirts to not even lose any money. And break-even point has two parts, so just finding the X is not sufficient. We need to figure out if she makes and sells 80 shirts, what is her cost? What is her revenue? If this is the true break-even point, those should be equal to each other. So let's do a little arithmetic to double check that. The cost of 80 is 8 times 80 plus 800. That's 640 plus 800. How much is she out of pocket? $1,440. That's her cost to make 80 shirts. What's her revenue if she sells those 80 shirts? Well, her revenue is $18 times each of those 80 shirts. If you do that arithmetic, it's exactly the same, $1,440. So Micah is going to break even if she sells 80 shirts. Now let's talk about profit, because when you are in business, ideally you're in the business to make a profit. So part D asks us to write the profit function. So let's define for a minute what profit is. Profit is what is left over after you pay all your expenses. What's left over means I have to subtract. So if I take my revenue, my R of X, how much I bring in, I subtract from that what my costs were, I get an equation for the profit function. In this case, the order does matter. Revenue has to be written first. 18x. Now our cost function involves two parts, so we have to subtract both parts, and that's why I put parentheses here. 8x plus 800. So distributing and getting my signs all right here. 18x minus 8x minus 800 gives me a profit function of 10x minus 800. Now, with a little bit of analysis, this is not a coincidence the way this equation or profit function turned out. If the shirts are costing her $8 to make and she's selling them for $18, she's going to make $10 a shirt. That's where that 10 comes from. But she's also starting out in the hole $800 because she had these fixed costs up front to start this business. But that's what our profit function would look like. What's interesting is if you take your profit function and set it equal to 0, that's also break even. It's called break even. That's the definition of break even, a profit of 0 and a loss of 0. So, not coincidentally, if you take this same equation and you solve it for x, you get the same level for break even. X is 80. So that's our profit function. That profit function confirms what we already knew about break even. Lastly, they want us to find P of 20. Find P of 20 and interpret it. So we've got this profit function or equation now. And it's 10x minus 800. And they're really asking us to find P of 20 and see what that means. Now, if you think about this in advance, you should understand. She is not going to do very well if she only sells 20 shirts. We know she's got to make at least 80 to break even. What's going to happen if she only sells 20? Well, substitute your 20 there. She's only bringing in $200. She's paying out $800. She's losing $600. That's our interpretation. If she only sells 20 shirts, she can't break even. In fact, she's going to lose $600. She's not sold enough shirts to even cover her basic startup costs. So that is P of 20 and the interpretation of P of 20. So profit can be negative. And when profit is negative, we actually call that a loss.